Defense Advanced Research Projects Agency, abbreviated DARPA, or the Office of Advanced Research Projects of the United States Department of Defense, was established in 1958, almost immediately after the launch of the USSR's Sputnik 1. The realization that the Soviets were about to launch not only satellites, but also missiles into space encouraged the United States government to take notice. The result was the creation of a unique agency with a huge budget, which could be spent at its own discretion. Check out our selection of the most unexpected, strange, and advanced projects in the field of technology and artificial intelligence from DARPA in this one video. DARPA's mission is to create innovative defense technologies. The agency's projects range from space-based missile shields to cyborg insects. At the same time, the internet, the first computer mouse, GPS, robot vacuum cleaners, and, for example, Siri were created. The uniqueness of DARPA is that by investing in the project, it does not seek to take a share in the capital, but only stimulate the development of technology and looks to where it will lead us. The first significant success of the agency was ARPANET, which laid the foundation of modern internet. In 1969, with the help of this computer network, the first message was transferred between computers in California and Stanford universities. Although then, only 2 of the 5 letters of the message managed to transfer. But on January 1st of 1983, the network became the first in the world to switch to data packet routing. As a routed protocol was developed by order of DARPA, the IP protocol, which is still basic for data transmission on the internet today. In 1964, Charles Rosen, head of the Stanford Research Institute Artificial Intelligence Center, proposed the creation of an intelligent automatic machine for the Advanced Research Department. The grant was approved, and it was assumed that the developed robot would be able to work as a scout or a patrol officer. This is how the shaky robot came into being. According to the description, it could recognize its own environment, derive implicit facts from explicit ones, create plans, and recover from mistakes in a planned execution, and also understand orders written in plain English. The robot was equipped with video cameras, collision sensors, and a rangefinder. Communication with the control computer was carried out via radio. Shaky software architecture, computer vision, navigation, and planning techniques proved to be fundamental to robotics and web server development, video game creation, and Mars rovers. Autonomous robots, like self-driving vehicles, were one of the first and main goals of DARPA. To stimulate their development, the agency launched the Strategic Computing Initiative in the 1980s and allocated billions of dollars to it. The goal was to develop artificial intelligence techniques in multiple fields. Among the results, there are first autonomous cars and the first quadruple-legged walking robot by Boston Dynamics. Modern unmanned vehicles date back to a series of robotic races, which DARPA sponsored in the early 2000s to stimulate the development of this technology. And in 2004, out of all the applicants for the prize of $1 million, only one managed to pass a modest 12 kilometers of the planned 240-kilometer race. Later in 2005, the entire distance was able to be covered by 5 cars at once. In 2007, DARPA held another race, but this time with a prize of $2 million. The self-driving cars had to drive through the city, observing rules of the road, and interacting with each other at intersections. It was DARPA that sponsored the development of the first 4 Boston Dynamics Big Dog robots, presented in 2005. The robot, measuring 91 by 76 centimeters and weighing 110 kilograms, was able to move at speeds of 6.5 kilometers per hour and carry a load of 150 kilograms, as well as climbing a mountain with a slope at a 35-degree angle. The project cost DARPA $42 million, but was eventually closed because the robot was incredibly noisy. Nevertheless, Big Dog became the basis for the creation of both the Robot Spot and the Atlas robot. By the way, the robot was not the last development of Boston Dynamics for DARPA. All of the robots of the company, including those created for military purposes, we showed previously in a video. A link to that is now in the card above. Very unusual developments were and are among the agency's projects. For example, The Energy Autonomous Tactical Robot Program was aimed at creating robots that could feed on plants to independently replenish energy right where they would need to be working. Or the Engineering Living Materials Program, aimed at creating self-heating building materials with the development of 3D printing of organs and tissues. DARPA hopes to use similar technology to create hybrid materials that can form and support the growth of artificially created cells. These materials are able to be grown locally using already available resources. The Hybrid Insect Micro-Electro-Mechanical Systems Spy Beetle project in 2006 looked crazy. In 2009, the engineers even presented a prototype transmitter for cyborg insects. But judging by the fact that in 2018, the agency announced the beginning of the development of miniature robots to manage insects in the right quantities did not work. The new program Shrimp for short-ranged independent micro-robotic platforms, and the robots developed within it will be related to the smallest types of these mechanisms, just the size of insects. The robots will be fast and maneuverable enough to jump, fly, and lift objects and perform terrain analysis. And these will not be the only bio-inspired robots from DARPA. Recently, the agency announced that next year it will present a completely finished robot worm, which will be able to tunnel at speeds of 10 centimeters per second. For the Project Underminer project, $2.5 million has already been allocated. The tunnels will be needed to quickly create tactical paths when fighting in cities and megacities. One of the important projects of DARPA was the Systems-Based Neurotechnology for Emerging Therapies program, designed to create implantation, diagnostic, and therapeutic closed-cycle systems for the treatment of psychoneurological diseases. Essentially, the program wants to create a brain implant that will help soldiers fight post-traumatic stress disorder and other problems. Interestingly enough, when DARPA began working on the neurointerfaces, it said it would create a chip that would allow the military to control combat robots and drones with only the power of thought. One way or another, the work on the brain chip continues. Another key area of DARPA's project is the creation of robotic pilots and artificial intelligence capable of controlling aircrafts and helicopters, including combat ones. Thus, at the end of the year, the final test of the Alias technology on Sikorsky UH-60M Black Hawk helicopters are able to be held. The test program will have remote and autonomous missions. Alias systems consist of a robotic pilot voice interface and software. In order to install Alias on any Black Hawk from the U.S. Army's fleet, only LiDAR and cameras are needed. The Artificial Intelligence Training System, which in the future will be able to take control of a combat aircraft and conduct close-air combat maneuvers developed by DARPA, is called the Air Combat Evolution. It was for its development that the recent neural network algorithms were tested with the Virtual Air Combat Alpha Dogfight trials. Remember, in the course of these, artificial intelligence managed to defeat a professional pilot of the U.S. Air Force with a crushing score of 5-0. The new neural network systems will have to control the fighter and flight faster and more efficiently than a man is capable of doing. It will be tested on a real plane in 2024. The preparation of the fighter for this event has already begun. Autonomous vehicle technology is of interest to DARPA, not only in the air but also on water. Just the other day, the agency announced it was ready to conclude contracts for supply of long-range uncrewed ships in 3 private companies within the framework of the Sea Train program. The goal is to overcome the range limit for sea drones by reducing wave resistance. After overcoming the necessary distance, the drones will separate to perform their tasks and on the way back, form back into a train. Also, at the expense of drones, the U.S. intends to soon increase the number of its fleets to 355 ships. This was recently announced by the U.S. Defense Secretary Mark Esper. He also reported on the demonstration of a prototype underwater drone Echo Voyager from Boeing and the Sea Hunter surface vehicle developed by DARPA. Apparently, they will join the ranks of the United States Navy. Another global goal of DARPA is the creation of swarm intelligence. That is the use of groups of robots to perform complex tasks. As a part of this project, researchers from Buffalo University recently received more than $300,000 to study the brain impulses and eye movements of gamers. The goal of this is to improve the organization and strategy of the autonomous air and ground robots through a new training method. These robots will be trained by an algorithm that should process the information collected by scientists, and it will help understand how gamers operate in some of the unexpected situations, what they pay attention to, and how they operate, and what these actions lead to. The research of robots is conducted by DARPA in two other directions. The first is the Offset Project, the development of software that will combine various ground robots and unmanned aircrafts into one group. The robots in the group must be able to solve one or more tasks together using more than 100 tactical options. The second direction is the Squad X project. It involves the introduction of drones, robots, and sensors on the battlefield to maximize a soldier's awareness of their current situation as well as other tasks. DARPA has already tested the program through a week-long exercise, during which United States Marines used drones and robots to coordinate their movements and detect potential threats in the field. The information from the sensors was processed by artificial intelligence systems and only then passed on to the military. This is probably how battle scenarios of the future are going to look. It's impossible not to mention that thanks to DARPA, the whole world was able to enjoy a spectacle of human-like robot races at the DARPA Robotics Challenge. Videos of the epic robot fails of various designs quickly became a hit on YouTube. And although it was very funny, we shouldn't forget to thank these types of events. Robotics are developing, and today we can see the results of this with smart robots like Atlas. Subscribe to the channel, like the video, and share this video with friends. And definitely do not miss any new releases from Pro Robots.